Hello friends, welcome back to our channel. In this video, we are going to discuss about OSI model. OSI, also known as Open Systems Interconnect. OSI model standardizes the network communication among various hosts in computer networks. This describes what exactly happens and what are all the components involved when one host communicates with another host in a computer network. This describes the network functions in terms of 7 layers. As in the diagram, we have 7 layers like application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. All these layers have corresponding roles to help the effective communication from source to destination in a network. Here, each layer will use the services of the layer below it. For example, the data link layer will use the services of physical layer, and network layer will use the services of data link layer, and transport layer will use the services of network layer, and so on. Before discussing about the functions of each of the layers, let me try to explain briefly about this example network. Here we have various computers which are connected to a switch inside a network. Here also we have computers connected to switch inside another network. Let us take one of the computers as source. From this source, we want to send some data to another computer in this network. For example, this is the destination. So here, all the computers are connected to a switch inside this network, and this switch is connected to this router. So when this computer wants to send some data to a computer in this network, initially, the data will be transferred to the switch. From the switch, the data will be transferred to this router. So since this router is connected to another router here, so it will transfer to this router, and then the data will be transferred to this router, and this will continue until the data reaches the router to which the target network is connected. Then it will transfer the information to this switch, from there finally to the target computer. So this way the data communication happens through various elements in the network. For example, through switches and routers. So here this is a very simplified network, but the actual network contains many computers, many subnetworks, and many switches, many routers. So the data flows from the source computer via switches and routers to the target computers. So now let us explain the function of each of the layers. Let us start with the bottom layer, which is physical layer. We have discussed that the data will be transferred from source to target. So here the data can be a file which is transferred from a source machine to a destination machine, or it can be a web request from a browser in the source machine to a server in the target machine, so that the web server will respond with some files like HTMLs and so on to the browser in the source machine. So here the files or some other data is nothing but the combinations of zeros and ones. So the data is nothing but the combination of bits which are transferred between various elements in the network. So here the physical layer is responsible for transferring the combination of these bits between various nodes in this network. Here the node can be a computer, a switch, or a router, and so on. Each of these nodes in the network will be connected to other elements via this physical layer. So this physical layer is implemented by using different types of cables like FiberNet, coaxial cable, copper cables, and so on. For example, in the source network, in this LAN, each of these computers connected to the switch via the Ethernet cables. So those cables are responsible for transferring the data between various computers of this LAN. Similarly, the switch will connect to the router via another type of cable, and these routers will be connected by using other types of cables, and so on. So the physical layer is responsible for transferring the actual data among various elements within the network. In addition to the Ethernet cable, if you use Wi-Fi here, for example, if this is a Wi-Fi which is wireless access point, then these machines will be connected to Wi-Fi. That means these machines will transmit data through wireless mode using radio waves. And then this wireless access point will be connected to the switch by using a cable. So this way we can implement the physical layer by using different cables or via wireless access. So the next layer is data link layer. This data link layer sits between the physical layer and network layer. This ensures the reliable data transfer between adjacent nodes. For example, here we have two nodes. One machine wants to send data to another node which are connected to a switch. Then this layer will ensure reliable data transfer between these two nodes. Here also, if these two routers are adjacent, the data will be transferred reliably by using this data link layer. Similarly, here also the data transfer will occur reliably between these two adjacent nodes. So how this is achieved? So let's take an example here. So here we have the machines connected to the switch. So each machine will have a network interface card. So this has NIC, and this node also will have corresponding NIC, and this also have NIC. So these network interface cards will have an address called MAC address. So this MAC address is a fixed address. So if this machine wants to connect to this machine, first of all it will try to identify the MAC address of this machine. Then it will send corresponding data through the switch to this MAC address. They also implement protocols corresponding to congestion control and flow control. The flow control algorithms will ensure the source will not send more data than the target can receive, and the congestion control algorithms will ensure to avoid collisions. So all these algorithms will ensure the reliable data transfer between which are connected adjacent to each other. Now let us discuss about network layer. Network layer sits between transport layer and data link layer. While data link layer ensures the data transfer between two adjacent nodes, this network layer will ensure the data transfer between end-to-end hosts. For example, from source to destination via the entire network. In network layer, a protocol called Internet Protocol is implemented, which is also called IP. So using this protocol, every host will be identified by corresponding IP address. Here the source host is identified by IP address. Similarly, the destination also will be identified by IP address. And also the interfaces of every router will have corresponding IP addresses. So using these IP addresses, the data transfer will occur among various hosts here. So these IP addresses are logical addresses. These are not physical addresses like MAC addresses. So for example, if you have a subnet here, if you have another subnet here, if we connect our machine to this subnet, we'll get an IP address, and if we connect the same machine to this subnet, we'll have a different IP address. That means this IP address is not fixed, but the MAC address will be fixed even the same machine is connected to different subnets. So this layer will do the three main things. One is logical addressing, second is routing, the third one is packet forwarding. First of all, using this layer, we'll identify the destination by using an IP address. So once the IP address is determined, it will use the routing protocols to identify the best path from source to destination. So that will be achieved by maintaining the routing tables. So each route tables will contain the IP address of the next hop. So once the best path is determined, then the data will be forwarded from one node to another. So to make the data transfer between adjacent nodes, this network layer will use the data link layer. So this way, this network layer will ensure the end-to-end data delivery from source to destination by performing these three important functions like logical addressing, routing and packet forwarding. Now let us discuss about transport layer. This layer is present on top of network layer. While network layer ensures the data transfer between end-to-end host, for example from source to destination, this transport layer will ensure the data transfer between the applications which are running in end-to-end hosts. For example, in the source I have application 1 and application 2, and in destination I have another two applications like A3 and A4. If application 1 wants to send some data to application 3, then the transport layer will ensure the data transfer from application 1 to application 3 will happen successfully. So network layer ensures data transfer from one IP address to another IP address. Transport layer ensures the data communication from one application to another application. Here the IP address and port combination identifies one of the applications which are running in the source machine, and this IP2 and corresponding port combination will identify the application which will run in destination machine. Here each application which is running inside the machine will be identified by corresponding port number inside that machine. So transport layer uses the combination of IP address and port to identify a particular application so that it can deliver the data between applications which are running in different machines. So transport layer is used to transfer the data from one application which is running in a source machine to another application which is running in a destination host. So actually it uses the service of network layer to transfer the data from the source machine to the destination machine. Once the data reaches the destination machine, it will send that data to corresponding application which is running inside the destination machine. In transport layer, there are two protocols are generally implemented. One is TCP and second one is UDP. So TCP means Transmission Control Protocol. UDP means User Datagram Protocol. Here the TCP, which is Transmission Control Protocol, is reliable and connection oriented. Reliable in the sense we can expect 100% guarantee that the data which is transmitted using this protocol from one application to another application will not be lost. It is connection oriented. That means it establishes the connection between the source application and the destination application before the actual transmission of data. So let us see how the connection is established from the source application to the destination application. So initially the source will send a connection establishment request to the destination application, so which is a synchronized request. Then the server or destination will send an acknowledgement to the source, which is SYN acknowledgement. So once the acknowledgement is received, then the client sends another acknowledgement that it has received this synchronized acknowledgement, and it will complete the connection establishment. So in addition to acknowledgement, it also can send the data request, and then the destination will send actual response. So this way, initially the connection will be established and then the actual data transfer will occur. That means TCP is connection oriented. First the connection will be established and then the actual data transfer will occur. And one more protocol we have, user datagram protocol. This is connectionless protocol. It is also not reliable. That means this protocol will not give 100% guarantee that the actual data is fully transmitted from source application to destination application. So there could be some loss of data. And this protocol is connectionless. It will not establish any connection before the actual data transfer. Since TCP is connection oriented and reliable, we can use this for important data sensitive applications like email applications, financial applications, and so on. Since UDP is connectionless, it is faster when compared to TCP. So we can use UDP for high-speed data applications where there is some provision to lose some data. For example, video streaming applications and so on. So this is about transport layer. One more thing about TCP, in addition to the reliable and connection-oriented protocol, it also implements other algorithms like flow control, which ensures the sender application not to send more data than the receiver application can receive. It also ensures whatever data that is segmented at the source will be collected in order at the receiver application. The next layer is session layer. So this session layer, presentation layer, and application layer, these are the top layers. These will perform the functions based on the application. So here the session layer maintains the sessions from the client application to the target application. That means the session will be maintained from a client application which is running on a source host to a target application which is running on the destination server. So while maintaining these sessions, it takes care of several things like off duplex communication or full duplex communication based on the requirement. Off duplex means only one application will send data at a time. Full duplex means both the sender application as well as receiver application will send the data at the same time. For example, chart application. In addition to that, it also uses checkpoints. For example, if the client application downloads a file of 1 GB from the server application, it will put checkpoints, let's say, at every 200 MB. After downloading 200 MB, if there is any problem with data downloading, then it will start from the 200 MB instead of starting the download from scratch. So this way the checkpoints will be useful to make sure the resumption of data transfer after the checkpoints instead of starting from scratch. So this way, this session layer will maintain the sessions and it will make sure the off duplex or full duplex communication. It also uses checkpoints, and once all the communication happens, it terminates the sessions. Some of the applications of maintaining sessions by this session layer are maintaining a database session from a database client to database server, and RPC or remote procedure calls, for example Java applications, and maintaining the sessions between chart applications, and so on. The next layer is presentation layer. Here the name indicates it presents data in a proper format for the application layer. For example, if we use HTTPS, the data will be encrypted between the client application and the target application. So in this case, the presentation layer will encrypt data at the client application layer level. Once data is transmitted to the target application, then it will decrypt the data. For the destination application layer, it can understand the data which is transmitted by source application layer. So this layer performs various functions to present the data in a proper format which would be understandable by the application layer. So this layer performs various functions like encryption and decryption. Similar to that, it also performs like data encoding and decoding, and it translates the data into various formats. That means it will be used as a translator for the application layer and so on. So basically the main function of presentation layer is to present the data which can be understandable by application layer. Now let us discuss the final layer, which is the topmost layer, which is also called as application layer or layer 7. So this is the layer through which our application softwares will interact with the network. That means this layer will act as an interface between the application software and the actual network. If the application software wants to interact with the network, we can use various protocols as provided by this layer. So there are a lot of services provided by application layer by using different protocols. For example, HTTP or HTTPS for web browsing, DNS, which is also called as domain name system. So this provides us the IP addresses for a corresponding domain name, and FTP for file transfer protocol, and SMTP for mail transfer. So these are some of the services or protocols which are provided by this application layer so that our applications can interact with the network. In addition to the application software, the users also interact with the network by the services provided by application layer. Till now, we have discussed the function of each of the layers, from application layer to physical layer. We also have discussed that how the data flow from source application to destination application. So when we say data, that data will be different for each of the layers as per the function of each of the layers. For example, in the application layer, we have the actual data, whatever data the client application is trying to send to the destination application. So that data we have in the application layer. Similarly, the presentation and session layers, these also belong to application. So the similar data will be there in both of these layers. The format of data may be different in the presentation layer. For example, we'll have encrypted data in case of TLS or HTTPS. So once the application layer requests transport layer to send data, then the transport layer will divide this data into chunks which are called as segments. So these segments will be sent from the transport layer of the source application to the transport layer of the destination application. In the transport layer, the segments will contain two important things. One is actual data of application layer and header. This segment header will contain the metadata about the transport layer. For example, if we use TCP, so it will contain corresponding TCP header so that it will identify the source application port and the destination application port. So for example, in destination server, we have an application running on port 8080. If the client application is running on port 1234 in the source server, then the TCP segment will have the information about the source port as well as the destination port. And also they contain information about the sequence number. This is very important for TCP because once the segments reach the destination server, it needs to know the order in which these segments needs to be arranged so that the application layer of the target application will use those segments to represent the actual information. It will also have checksums. These checksums are useful for error detection and error correction. So before sending the segment, it will calculate the checksum using some algorithms like MD5. Once that segment reaches the transport layer of the destination application, it will again calculate the checksum and it will verify the checksum of the source as well as the calculated checksum. If both are matches, that means the data is not corrupted. In this way, the checksum will be useful for error detection. So since the transport layer will use the services of network layer, so this network layer will add extra header. So this header will contain the source IP address and the destination IP address so that the packet can be forwarded from the source machine to corresponding destination machine. Similarly, since network layer will use the services of data link layer for node to node communication, it will add one more header that will contain the information about the source and destination MAC addresses. And finally, the entire data, which includes all the headers and corresponding payload, will be sent as bits from the physical layer. So here the routers and all will not have this application layer, presentation layer and session layer, transport layer, because they are only concerned about the actual routing of the packets, actual routing and forwarding of the packets until it reaches the destination. So once it reaches the network layer of the destination, whatever data we have sent as headers, so each will be decapsulated in the target machine. For example, the transport layer will get the data of corresponding TCP and then the application layer will get corresponding original data. This way we'll have different types of data in each of the layers so that the data can efficiently move from the source application to destination application. Now let us see some of the examples of these data formats in transport layer, network layer and data link layer. Here we can see an example of a TCP segment. So in this segment we can see, so this is the actual payload data from the combination of application, presentation and session layers. So this TCP segment has corresponding header. Here we can see the source port and destination port. So these will identify from which application to which application the data will flow. This also contains the checksum for error detection. It also has sequence number to maintain the order of the data segments. It also has some other data as part of the header. Similarly, we can see a datagram belongs to network layer. Here this also contains the data. So this data includes the TCP header and actual payload from application layer, and it has its own header. So this header will contain the source address and destination address. So this source address and destination address will be corresponding IP addresses. The data communication will happen between those two machines with corresponding addresses. This is an example of IPv4 packet. Similarly, we can have packets for IPv6 as well. This is an example of data link layer frame. So here we can see the payload. The payload indicates the combinations of headers from network layer, transport layer, and also the actual data from the application layer. So in addition to the payload, it has its own header. So this contains the source MAC address, the destination MAC address, and so on. So this is basically an example of a frame for Ethernet. So this way we can see the different data formats for different layers. So in this video, we have seen what is Open System Interconnect model, and we also have discussed about different layers of this model from physical layer to application layer, and we have discussed about various data formats of these layers. We also have discussed about various protocols and functions of each of these layers. I hope this video helps. If you like the content, please like, share and subscribe. Thanks a lot for watching.